Today's notes, we're going to finish up with what we started the other day, which was answering a problem. So not just finding the pieces and then figuring out the steps, but also coming up with the actual answers to what the question was asking originally. So let's go ahead and get started. A pool ball is accidentally hit horizontally off of a 1.1 meter high table. Okay, that seems to be important information. That's how tall it is, and lands on the ground 6.1 meters away. Another probably pretty good piece of information. Calculate the time required for the pool ball to fall to the ground and the initial horizontal velocity with which the ball was hit. Alright, so I'm going to go through and diagram the situation. So here's our table. Alright, I know the table is 1.1 meters tall. I'm going to go ahead and assign xi as being 1.1 meters. And then xf I'll say is 0 meters when it actually hits the ground. The pool ball gets hit off of the table and lands 6.1 meters away. And I'll go ahead and say that the starting position horizontally is 0 and the ending position is 6.1 meters. Alright, time is a question mark. How much time did it take to reach the ground? And then, what was the velocity at which the ball was hit off of the table? Now, there are two things going on with this problem. Number one is the horizontal, excuse me. So what's going on horizontally? And horizontally, we should be remembering, hopefully, or continuing to learn that it is a gravity-free path horizontally, which means acceleration due to gravity horizontally is 0 meters per second. So if I was playing pool in space and I had hit the ball like that, it would just go off of the table and continue to fly horizontally forever and ever and ever and ever at 0 meters per second squared. And since I don't know the speed at which I hit it to start with, that means I don't know what the horizontal final velocity is as well. Alright, so the fact is I'm not playing pool up in space, I'm actually playing pool down here on Earth. So when I'm on Earth, things fall off of tables. So one of the other aspects of what's going on with this problem is the fact that not only is the ball traveling away from me horizontally, but it is also traveling down from where it started. And there is our downward vertical movement. Now I'm going to go ahead and say that since the ball was at apogee when I hit it, that means that the vertical initial velocity is going to be 0, because when we are at our highest point, when we are falling or when we are thrown into the air, apogee, then that highest point has an initial velocity of 0 meters per second. Another way to think about this is that I didn't hit the ball off of the table down, I hit it off horizontally. So all of my speed that I hit it with is going horizontally, not vertically. Alright, so this is a cluster of information, and I'm just going to go ahead and start to put it into order, such as acceleration. These are two pieces I should always remember. Vertical acceleration is negative 10 meters per second squared, and horizontal acceleration is 0 meters second squared, because horizontally it's a gravity-free path. Alright, and I also know that time is a question mark, and my initial velocity is a question mark. So if my initial velocity horizontally is a question mark, then that also means that I don't know what the final velocity is either, because the two are equal to each other. I know that I have an initial velocity vertically of 0 meters per second because I didn't hit the ball down, I hit it horizontally, and things start off with a vertical 0 velocity at their highest point. And that means I probably don't know at which velocity it hit the ground downwards. So what if I had just dropped the ball off of the pool table? What velocity did it hit the ground with? I don't know. That's my final vertical velocity. Alright, now about the distances. We know that the pool table is, let me go forward here, there we go. Alright, we know that the pool table is 1.1 meters high. I'm going to say that's xi, the starting position of the ball, and then vertically it's going to hit the ground at 0 meters. Horizontally, it's starting at 0 meters and ends up hitting the ground at 6.1 meters away from the table. And that matches up pretty well with my diagram. Okay, step number 2 is I'm going to go ahead and lay out a plan for how to solve this problem. So here's all of my variables that we just talked about and put into their organized place. And now I'm going to come up with a nice plan. And my plan is, first, let's start with what's missing. So missing, I know that I'm missing the vertical final velocity, I know I'm missing time, and I know I'm missing both horizontal velocities, the initial and the final. Okay, so this is pretty similar to a problem I saw last night when I was doing my notes. So I'm going to assume that I need to start with my vertical final velocity. And if I can find that, then I can find time. And since time will exist for both vertical and horizontal data, then I can use time to help me find probably my velocity initial. And if my horizontal initial velocity is found, then I know what my final horizontal velocity is because the two are equal to each other. Alright, so what equations am I going to use to do this? Let's go ahead and see. So step number 1, find vertical final velocity. And I think I'm going to go ahead and use this equation because that equation doesn't require that I have time and I have all that information. I have initial velocity vertically, I have the acceleration vertically, and I have the change in distance vertically. I'm going to go ahead and move on to step 2. Once I know what that is, once I know what the vertical final velocity is, I'm going to find my time. And I'm going to use my vertical information to do that. Okay, so which equation will I use to find time? I'm going to go ahead and try to find the easiest time equation up there. And I think this one's pretty easy. So what I'll do is I'll plug in all of my vertical information into this equation, and then I will isolate that variable time. Alright, step 3, I'm going to go ahead and find my horizontal initial velocity. And I'm going to be using my time to help me do that, as well as all my horizontal data. So I'm going to go ahead and check out which one of these equations up here can I find the initial velocity pretty easily with. And I'm going to go ahead and choose this guy right here. And what I'll do is I'll plug in all my horizontal information into this equation and then solve for my initial velocity. So I'll isolate initial velocity. Now this looks like a lot, but if you look at all the data to the left, there are a lot of zeros in this data. So I'm hoping that it'll actually be easier than it looks. Alright, so let's go ahead and get started. Alright, so step number 1. I'm going to go ahead and start solving for my vertical final velocity. Alright, so vertical final velocity is equal to, well, I know what the vertical initial velocity is, it's 0, and I'm going to square it, plus 2 times the vertical acceleration, that is -10, and I know that, meters per second. And then I need the change in position vertically, and if I look at xi and xf, then the difference between the two is my change in position, and that's going to be 1.1 meters then, because 1.1 minus 0 is 1.1. Okay, so let's go ahead and solve. Vertical final velocity is equal to the square root of 0 squared, which is 0, plus 2 times -10 times 1.1, and all of that multiplied together is -22. So my vertical final velocity is going to be equal to, and I'm going to put 22 in there. Now why did I leave the negative off? Well, if you try to enter the square root of -22, you're going to get an error message, and that's because there's no such thing as trying to find the square root of a negative number. And since negative just means direction, I'm going to go ahead and just pull my negative out real quick. I'm going to find what the square root of 22 is, and that equals about 4.69. And I'm going to go ahead and there are my units and add my negative back to this. So that negative means that the vertical velocity is headed downwards. And that makes sense because that's what's going on with the ball. It's going down and away from me. Alright, so there's one piece of information I can add to my data, which is now the vertical final velocity is -4.69 meters per second. Okay, let's get rid of that and solve for step number 2. Step number 2, find time. And I'm going to use this equation to find time. And I'm going to use my vertical information to find time. Because notice, I have a lot of vertical information I know. In fact, I have more vertical information than I do horizontal information. And so I'm going to use that vertical information to help me solve for time. Okay, so the vertical final velocity equals the vertical acceleration multiplied with time plus the vertical initial velocity. Okay, so I know one of those pieces, that's the vertical final velocity, negative 4.69 meters per second, equals the negative acceleration, which is vertical, negative 10 meters per second squared, multiplied with time, which I don't know, plus my vertical initial velocity, which is 0 meters per second. Okay, this is nice because I have a nice 0 in there. I can ignore that 0, and I'm left with just negative 4.69 meters per second equals negative 10 meters per second squared times t. So I'm learning in algebra that I can divide both sides by negative 10 meters per second squared. That will get rid of the negative 10 meters per second squared attached to my time. So those cancel out. And I'm left with time equals whatever that is. And notice all my units on the left are going to cancel each other out. So meters cancel out meters. One of the seconds cancels out one of the other seconds. And I'm left with just seconds for time. So time equals negative 4.69 divided by negative 10. The negatives cancel out, and time equals 0.469, which is about 0.47 seconds. Cool. Time is a really important piece of information, so I'm glad I have that, and I'm going to fill that into my data chart on the left. Vertical time is 0.47 seconds, and horizontal time will have to be 0.47 seconds as well. Alright, so let's go ahead and solve for the third piece. Alright, last but not least, step number 3 is to find what is my horizontal velocity. So what was the velocity I hit the ball with off of the pool table? Alright, well, I've calculated the time, check. And now I'm going to calculate the initial horizontal velocity. Alright, and to do this, I'm going to be using my horizontal data to do that. And I have a lot of my horizontal data. So, XF, so horizontal final position equals horizontal initial position plus horizontal velocity times time plus 1/2 the horizontal acceleration multiplied with time squared. Alright, so I know what my horizontal final position is. It's 6.1 meters. I know what my initial horizontal position is. It's 0 meters, and I'm getting this off of my data chart, so you can check that out. I don't know what my initial velocity is horizontally, and I'm going to multiply it with time. So there's my time, 0.47 seconds, and I've also used those two pieces of data as well. Now I'm going to add that to 1/2 times the horizontal acceleration, which is 0 meters per second. Awesome, there's a 0. And meters per second squared multiplied with time squared, 0.47 seconds squared. Alright, so I have a lot of zeros in here. Well, I can cross that one out because 0 plus anything doesn't really matter. And then you'll notice that I have a 0 acceleration being multiplied with a 1/2 and then being multiplied with time. Whenever I multiply anything with 0, it just becomes 0. So 0 times 1/2 is 0. 0 times 0.47 squared is 0. So all of that can just be canceled out because it just turns into a big fat 0. And that leaves me with 6.1 meters equals the initial horizontal velocity multiplied with the time. Awesome. So just like I said at the beginning, I am left with an easier equation than I thought I might have. So I'm going to divide both sides by 0.47 seconds, and I am left with nothing on the right side except my horizontal initial velocity. And you'll notice that meters over seconds will give me meters per second for velocity. That's awesome. So my initial horizontal velocity equals 12.98. Where did I get that from? I divided 6.1 divided by 0.47, and that's pretty close to 13 meters per second. All right, so now I know that I hit the ball off the pool table with 13 meters per second of velocity, which means the final horizontal velocity must also be 13 meters per second as well. So I've answered all of my questions. I calculated the time. I was able to calculate what the speed of the ball was when it left the table. And I did that by first getting all my variables, creating a plan, and then using that plan to solve for these final answers. We will continue to do this in class, and I'll see you for the next class period.